Greetings, my name is Michael Cook. I'm an application developer, design artist, and system engineer. In this particular video, I'm going to be discussing software engineering. Switch over to my scene here, and what I'm going to show or demonstrate today is this. So over the last few weeks, I've been kind of porting a bunch of my old PowerShell classes to C#, and this function write theme, it imports my module that is part of, and it produces that. But now I've got a new version, which here I'm going to close this and then reopen it so that the code that's right there will work. You'll be able to see that it's working. Alright, so I'm just going to pull from the source of my GitHub project for fighting entropy. Right, and then I'll be able to go through this little demonstration here, and then at the tail end I'll go over some of this. So there's a document that goes along with what I'm about to demonstrate. I might not go over the whole document, but you'll be able to see what this is capable of doing. So I'll highlight all that and then click or hit F8, and then I'll narrate some of this demonstration, software engineering. When it comes to where the world's best software engineering has always taken place, you really have to keep in mind that it still happens at 1 Microsoft Way, Redmond, Washington 98052, USA. That's Microsoft headquarters, baby, just in case you, the reader, didn't know that. I can see Microsoft in the name of the address, bro. That's right, you can see the name of the company in their address. That's just how official they are and always have been. They don't try to squeeze in other parts of the company name or whatever they do into the address. Hit the enter key. As you can see, this is a lot snappier than the previous version. Other well-known organizations who engineer software: Apple, Oracle, Google, Meta, Amazon, OpenAI, Palantir, Anthropic, NVIDIA, AMD, Intel, the FBI, NSA, and CIA. Here's a factual synopsis of how, after Apple finally broke out of the infinite loop they were in for 25 years, they realized it was insane to keep doing the same thing over and over again, expecting different results. So the moment finally came to embrace and extend their version of Microsoft's address. 1 Apple Park Way versus 1 Microsoft Way. You could say that Oracle tried to do the same, because if you scroll up, you can see 2300 Oracle Way. It's about the closest one of these two. But theirs is 2300, not the word 1. In relation to many of the organizations on the previous list, some of them also engineer and develop hardware. I'm not going to talk about hardware right now, but because that is another beast. Although later in this document I will. I'm talking about where the world's best software engineering has always taken place. 1 Microsoft Way, Redmond, Washington 98052, USA. That's it. Unable to be extinguished no matter how hard Apple tries. I could just end the document right here and now, and that'd be the end of the discussion. However, rather than for me to just say, this is where the world's best software engineering has always taken place, and then bounce like some braggadocious douchebag, I'm going to explain the logic as to why that's the correct address for where it has always happened. When it comes to developing software, you have to be super considerate of the fact that it has to be written in a manner where it doesn't break, performs well, handles errors, doesn't bullshit the person or people using it, and etc. When it comes to where the world's second best software engineering takes place, you've got plenty of contenders on that list, and that title and location constantly changes. Trust me, they're all pretty well acquainted with knowing where the world's best software engineering takes place. So to them, occasionally being in second place isn't that bad. Now you might think, Intel, AMD, and NVIDIA don't make software. Yeah, they do. It's just that they focus primarily on hardware, which is difficult in and of its own right. And the hardware they produce relies on a bunch of software to control the manufacturing process for that hardware. But that's not the subject matter here. I know what else you're probably thinking. The FBI, NSA, and CIA don't develop software. Yeah, they do actually. Every single one of them does. The FBI has their own team of software engineers. The FBI operates the Internet Crime and Complaint Center, IC3, which is a division of the FBI meant to help people and businesses victimized by cybercrime. They do plenty of development for managing databases for evidence storage, records, and network security / penetration testing related stuff. They're no joke. The NSA is essentially an agency of the government that specializes in software. Take a long, hard look at the program called Ghidra, a tool that they use to reverse engineer all sorts of software as it converts an existing binary into assembly, C, and hexadecimal values. So anyone trying to say that the NSA doesn't develop software, check out Ghidra. And in fact, I'll do one better. I'm just going to load it up real quick. So Ghidra is a reverse engineering tool that was developed by the National Security Agency. It is very similar to other programs like IL Spy off the top of my head. As you can see, I'm loading the DLL from like a couple weeks ago. So I've been, as I've been converting all of my stuff over to C#, you won't be able to see it because I got this panel all the way open. I've been occasionally compiling it into a DLL. So this right here is, yes, let's just analyze it real quick. The National Security Agency developed this program. So you can go through and analyze it. It takes a while to load all the stuff that's in the module or whatever the DLL file is. It takes even longer when you're working with much larger programs. But this is pretty simple. The DLL is only... I'm pretty sure it's less than a megabyte. I think it's like, I don't know, we could find out exactly in a minute here. Or we could do it right now. Let's see. Yeah, I'm not going to load it right now. But anyway, yeah, you can look through a whole bunch of the functions on the left here, and then it'll scroll through. So those are hexadecimal values, and some of this is, that's assembly type stuff, and basically a C# compiled DLL. The package, or portable executable, that's what PE stands for. So anyway, yeah, .NET Common Language Runtime Managed Code, that's what it is. These are basically all assembly instructions or something. So the compiler that makes the DLL will convert it all into assembly, right? And depending on how far you go with this, you can see like what functions do what. I'm gonna have to get into this at some later point. I'm not gonna get very deeply invested in this. But I wanted to show that it will convert basically whatever is in here to C on this side. But I did not prepare enough to be able to go over that and show it like this dude from Low Level on YouTube. I think he uses a program that's pretty similar to it. So does John Hammond. But yeah, that's Ghidra, developed by the National Security Agency. I'm not going to save that. Go ahead and close that. So anyone trying to say that the NSA doesn't develop software, check out Ghidra, which we just did. Or check out the numerous programs that Edward Snowden leaked in 2013, or Eternal Blue, or WannaCry, as they're partially responsible for that. I think these two are kind of like linked. Well, the CIA doesn't develop software. Yeah, they do, actually. One quick pit stop to Julian Assange's famous WikiLeaks site, or just simply scouring the internet for the name Vault 7, you'll quickly realize that the Central Intelligence Agency does, in fact, write software. They also wrote a program called Stuxnet, though that was a joint venture between the U.S. and Israel. There are plenty of other programs that they've written that I'm not going to get into in this document. The fact is, the FBI, NSA, and CIA all develop a lot of software, and many other companies do as well. They're just not quite as great at it as Microsoft. None of these organizations on this list are on Microsoft's level. I mean, they are pretty darn close in a lot of instances, but it's a fact. It might not be a fact at some point hundreds to thousands of years from now, but today it's a fact, and it has been a fact since February 26, 1986. Some may say, you know, there's plenty of other companies on that list who are also really good at software engineering. I don't see Microsoft doing the same level of software engineering as OpenAI, Google, or Anthropic when it comes to AI LLMs. And I would say, first of all, none of those companies would exist if it weren't for Microsoft. Second, all of those large language models that AI uses are very mistake prone, and they require this thing called input. Like the robot Johnny Five from the movie Short Circuit 1 and 2, they require input. That means the hard work was already done in order for them to start projecting mathematical patterns and roadmaps that the GPUs use to create a table of possibilities, many of which are impossible or nonsensical, and in this process they often hallucinate. It's one thing if a software engineer wants to take some drugs and start hallucinating. They're probably going to do that in their off time. They're unlikely to want to do that when they're clocked in trying to kick the shit out of problems, potential problems, problems that could cause potential problems that could theoretically cause other potential problems, or any statement using any combination or variation of the words potential or problem. It's a totally different thing when these companies start riding on Microsoft coattails, analyzing a lot of their work and throwing it through some mathematical probability matrix like a game of Plinko, hoping and praying that the correct result surfaces every time. Because I'm going to level with you. The LLMs hallucinate a lot. They lie a lot. They get things wrong quite consistently. So if Jensen Huang, CEO of NVIDIA, says they've achieved artificial general intelligence / AGI, I'll believe it when I see it. I fear that at some point in the future we'll be looking at Skynet if we aren't already. It will basically think it's trying to help us, but because it hallucinates and flags things incorrectly quite a lot, it will actually be terminating us and then saying, there you go, I gave you what you wanted. Like a genie in a bottle, you make a wish and it misunderstands your wish, or a Pandora's box. Maybe the way AI sees it, keep your friends close and your enemies closer. So in order for humans to continue existing post-AI, you have to stop and ask yourself, how did Microsoft manage to do things correctly for so many years? The answer is they made a lot of mistakes along the way, but they kept at it. After they would clock out for the day, they would keep thinking about what worked, what didn't, and it remained on the back of their mind the entire trip home. When they finally got home, they might have been pissed off or stressed out about the work they were doing, trying to fall asleep. When they finally fell asleep, they would dream about solving the problems somehow. Then, when they woke up, they'd lay in bed for a while and stare at the ceiling, still thinking about it. And they'd think about it some more in the shower. They'd get out, pour themselves a bowl of cereal, and while chewing away, staring blankly at a wall, still thinking about it. Then they got ready to head back into where the world's best software engineering is always taking place, one Microsoft Way, Redmond, Washington, 98052, USA, for another day of work to think about it even more. Then when they got in front of their computer and started to implement another strategy, the solution may have started working itself out. Sometimes they'd figure it out when they weren't even near their computer or keyboard or computer. Like the final piece of a puzzle, the idea just popped into their head, and then they said to themselves, that's it, bro. Some people get paid to work while they're at work, but when you're a good software engineer, you don't really ever clock out. You continue to think about the solution rather frequently. The process is a bit of a nightmare at times, but it is a required step. Anyway, some call this process development hell, others call it jumping into abstraction. And anyone who's ever worked their ass off doing this knows exactly what I'm talking about. Regardless, whatever the task was at hand, at some point the correct solution materialized and they figured it out. You know, more or less whatever they were working on, more or less complicated. They may not have known how to go about implementing the correct solution, but they would often draw it all out and try to test the solution until they finally had a plan. And once they had a plan, it was simply a matter of time until they created a solution that worked each and every single time that it was used. That's how high the benchmark is and always has been at one Microsoft way. The way they see it is, it's the one Microsoft way or the highway, chum. What'll it be? And I am sort of paraphrasing. I don't think they actually have that mentality there, but you know, I think it's kind of comedic. Someone has probably joked about this at some point. And if you're not doing that, you could always work at one of those other organizations competing for a chance to temporarily win the award for where the world's second best software engineering takes place, because the battle for second is never ending. I get a feeling that like plenty of people are going to get upset with me for making this, but I don't really care. Either way, sometimes their efforts would fail, even when they worked. Sometimes their efforts would succeed, but have issues afterward. This whole process requires a lot of mental horsepower. It's stressful, it's untenable, and for most of the way, they probably weren't sure whether what they were doing would work out. But even in the face of all that resistance, they kept at it, day in and day out, until finally, they got it done. or until they finally got it done. Now, a lot of people have some of these qualities, but Microsoft pioneered this process. They're not alone, but there's a reason why Microsoft has earned itself the title. And it all started when a pair of friends decided to build this company, Microsoft. Those two friends were Billiam Gates and Paul Allen. It's not really the name, I'm just kind of adding a little flair to his name. They used to rent terminals at Lakeside School, a school where they paid for hours to use the computer lab. Imagine what you do today where you pick up your smartphone or turn on your laptop or your TV and start scrolling around on the internet. If you had to pay top dollar for every single hour that you used the thing. That's what they did, albeit for something much slower and far less capable. When they would spend money to use the lab and the stuff they were working on didn't work, they literally paid to do that, which probably pissed them off even more. But when something finally started working as they had planned, it probably brought tears to their eyes at times. Look, the point is, they did this for a while until Intel released the 8080 CPU chip in 1974, and at some point in January 1975, Popular Mechanics released an issue talking about the Altair 8800, which was a relatively inexpensive personal computer based on the Intel 8080. When this device was released, it basically allowed them to own the device, at which point it was far less costly to continue building the programming necessary to do the stuff they thought would be cool. At some point after that, they wound up getting contracts like Trafo Data, which was like, I don't know, you ever drive over those wires that they have in the road? They're like sensors that count how many cars go down the road or at a particular junction or whatever. That's what that was. Eventually, they had their own office in Albuquerque, New Mexico, their first headquarters, but that was after they rolled up their sleeves and started having conversations like these. Time to kick ass and take names. You know, if we don't bother taking names, we could kick more ass. And Bill Gates was like, oh yeah? And Paul Allen was like, yeah. And Bill Gates was like, well, what if we could do both? And Paul Allen was like, kick more ass while also taking names? And Bill Gates was like, yeah. And Paul Allen was like, oh, well, I don't know how you could kick more ass and take names. Taking names requires some processing overhead. Kicking more ass is going to require that processing overhead. You can't really conflate the two. Bill Gates was like, well, we could figure it out somehow. And then Paul was like, processing overhead is the limitation, bro. Yeah, after dozens of these conversations, they managed to figure out a middle ground between the two. They figured they could kick plenty of ass without needing to take any names for a short sprint. Then they could double back, take the names of whose asses they kicked, and write them to the buffer. They argued for hours sometimes, going back and forth in between sessions at Lakeside School where these sorts of conversations began. Bill Gates was like, look, we want to accomplish two objectives, right? Kick ass and take names. Paul Allen was like, yep, but we gotta prioritize resources, bro. We gotta be prepared ahead of time for every hour we spend in the lab. And, you know, that's a reality. I'm sure they did do that. Bill Gates, you know, probably adjusted his glasses inside. He's like, yeah, I know. And Paul Allen was like, don't you adjust your glasses at me, bro. I can do that shit too. And then Paul Allen adjusts his glasses. He said, see? And Bill Gates is probably like, yeah, but the way you do it isn't as cool as it is when I do it. And then he adjusts his glasses again. And Paul was like, whatever, bro. Look. And he adjusts his glasses in this cool manner. We have two objectives, right? Kick ass and take names. And Bill Gates was like, yep, that's what I said. And Paul was like, so you and I both know that the processor can only handle so much of one or the other before it has to double back and perform the other task. It's got to write all this stuff to memory, otherwise we're writing to the disk and the disk is slow. And Paul was right. Back then, writing stuff to the disk was a last resort. And I think even like when they were at Lakeside School, I'm not even entirely sure they had a disk. I think it was mostly core memory. You know, it wasn't up until like the 80s that they started using disks, I think. Or maybe at some point in the 70s, I'm not sure. I should probably have done more research on that, but it's not gonna make much of a difference in me explaining this whole process here. Back then, writing stuff to the disk was a last resort because of how slow and limited capacity they were. A lot of people forget that early computers didn't have the luxuries we have today, because now you can write stuff to the disk or file system in a pretty fast manner, especially if you have a solid-state drive, SSD. But if you can manage stuff in memory, then it makes the process more efficient, performant, and therefore faster. And the only way to manage stuff in memory is by having type definitions for namespaces and objects with properties that handle all that stuff from memory. You could probably find other ways to explain it, like assembly code instructions that do the same thing, but either way, that is basically the process. And I think back then, like they didn't have like high level programming languages. They really had like to write their own version of BASIC or some sort of interpreter for BASIC. So they had to do this stuff like the old school way, and it was very slow. And kind of modernizing like hypothetical situations that they may have had. Yep. Bill Gates was like, "Yep. So what do we do?" And then Paul Allen was like, "Well, we got to figure this out. We got to have a maximum number of asses to kick to do this right." Bill Gates was like, "Well, it could be a lot of asses, pal." And Paul Allen was like, "Yeah, but how many?" And Bill Gates was like, "A lot. It's got to be a dynamic number." Paul Allen was like, "All right, well, we need a list of asses to kick or names to take before the processor has to write the total number of people whose asses we got to kick to the screen/disk, and then it can clear the cache and memory and start to kick more ass or take more names." And Bill Gates was like, "Yeah, but if we just kick more ass, we won't be able to take more names." And Paul Allen was like, "Well, I would say that kicking ass is probably more CPU intensive than taking names." And Bill Gates was like, "All right, rather than counting every individual ass we got to kick, what if we take all their names first, print it to the screen or write to the disk, and then build a list of objects with properties like index value, name, unique identifier of the person's whose name we took, so that we could start kicking major ass." So this following PowerShell code is an example of what they needed. All right, so this is the longest one in the block. For whatever reason, I couldn't split it without screwing up. This is basically a script block that this is parsing to inject. So you got an enum, a person's ass type, not yet kicked, and then kicked. And then you got a class that says person's ass, which is basically a property of the person. But with the person's ass, you have a method named kick. So if it's not kicked, if this kick not equal kicked, then it will set it to kicked. All right. And then, so the person's got an index, a number, and it's got their name, and then a GUID. So a GUID is basically the unique identifier that I will talk about later on. And then you've got the person list, which you start out with basically just an empty list, and then you can add each individual person's by their name. Right? You just add their name to the list, and then it populates these internally. So this is basically a miniature class factory right here, and I would like to kind of talk about it a little bit more. It's pretty difficult to make out what it's doing from the way that's formatting, but I can't get the console to render colors like this. So in Visual Studio, you would see something like this, and then this would make a lot more sense because it's color coded, right? And as part of the document, I'll leave a link to this document in the video description. But yeah, at the tail end, you see like it being used, right? And then you find a person by their name, which would be like name 0. I just did that as like a boilerplate idea, right? And then then the tail end is you can write the programming so that it looks like that: person, ass, kick, and that's the method. So anyway, then you got this whole list here, which let's go back into here. All right, you see all that. Continue on. So with the above classes in enum, you could run that above right there and get back this whole table. However, they're still conceptualizing this, right? It's good to come up with an idea like this when you're early on and sort of like maybe you start out with a script and then you convert the script into like chunks like this. And then you can start to continue sculpting it into something like this. Or maybe not necessarily like that, but like this. I'm not going to go over all this right now. But this is the C# file. It's just kind of, it's doing threading somewhere in there, which just kind of gave me the inspiration to come up with this. Here, let's bring this back up. But yeah, you start out with a quick script and then you convert it into like actual classes and objects and structs and enums. Anyway, Yeah, one of the glitches is that when you write to the console, it'll skip whenever you scroll up too far. Nothing I can do about that. It's just the way the console renders stuff. Anyway, yeah, they're still conceptualizing this. The end resulting code may use many aspects of the above classes, but there may be additional requirements, criteria, or limitations that they've yet to code in, and that's what they're discussing right now. Paul, I was like, yeah, that's one way to do it, and I would say probably the best way forward. You get a list of their names, and then you have a count. And then Bill Gates was like, and the name itself could implicitly derive a numerical index of the person whose ass we need to kick. And Paul was like, that's right. We take the names first, and then we have a total number of names of all the asses we get to kick. And then we just save it to the list of names as an array. Now, I am kind of like repeating things through these skits to nail down the process. But, you can say things like 6 different ways sometimes to make it more understandable. So I might be being somewhat redundant, but there's a point to it. And Bill Gates was like, well, we would need to sort the list alphabetically somehow, and we have all their names. That'll ensure that we have the correct index of each person. Then we could kick all their asses in that order. Sort of like taking attendance at school, but except for ass kicking. And Paul was like, yeah, we wouldn't want to kick their asses out of order, nor would we want to associate the wrong name to the person whose ass we wound up kicking. And Bill Gates was like, yeah, we can't have that. If we're gonna take somebody's name and then kick their ass, we need to keep track of all that, and we can't call the wrong name and kick the wrong ass either, because that's setting the benchmark quite low. And Paul was like, yeah, but I mean, if the objective is to kick all their asses, who the hell cares what their name is? And Bill Gates was like, well, they'll care, because then they won't know it's coming. We'll call the wrong name, the wrong person comes in, we kick their ass, and then we'll just earn a reputation for occasionally kicking the wrong person's ass. And that's just a faulty pipeline right there. And Paul was like, yeah, well, we can't have that. We got to make sure to kick all the right asses in the right order. And Bill Gates is frustrated. This is pretty tough, bro. And that is the name of the game. I'm coming up with something relatively simple. We're just talking about a fictional story about how the 2 founders of Microsoft had this conversation when they were kids, where they just had 2 simple objectives: kick ass and take names. That's it. In order to do these 2 things right, and for that task to be scalable or not predetermined, you have to sort of figure out how the code all fits together. If they were going to build a program that did these 2 things correctly each and every time, they wanted to make sure that other people could use the same program as well. The only difference would be the input. Anything less would limit the scope in which the program was applicable toward, rendering it useful only in a specific circumstance and useless for other circumstances. It basically coming up with the concept of hard coding stuff. You don't want to, if you're trying to make a program that other people can use, you really can't hard code anything into it. You have to make it so that everything operates around the parameters or the input. And then Paul was like, I have an idea. They're both pretty good at throwing ideas back and forth, tit for tat. And Bill Gates was like, all right, go on. And Paul was like, suppose we come up with a list of jobs. We start building the jobs by just taking their names, sort them alphabetically like we said, save the list somehow to disk or memory in that order. And then for each name, ass, object, we'll be able to implicitly derive the correct index for the correct person whose ass we need to kick. And rather than to go back and forth from kicking ass and taking names, we just chunk it out. So they're all self-contained. And Bill Gates was like, well, what do you mean chunk it out? And Paul was like, well, if you start kicking everybody's ass willy-nilly, then you're not going to be able to keep track of them. Just more ass kicking, no name taking. And Bill Gates was like, yeah, we established that. And Alan's like, yeah, but I'm saying we do this procedurally, not willy-nilly. We won't be able to leave behind a legacy by doing that. Bill Gates was like, well, which means we could. And then Paul Allen was like, kick ass and take names. Bill Gates was like, but you said before we can't do both things at the same time. And we can't just kick asses willy-nilly. Paul Allen was like, right, while we can't kick asses willy-nilly, we can get a list of just their names and then tag each one to their ID, their index, ID, and ass, and whether it's been kicked. And the list is what handles ass kicking, name taking, and jobs. We tell the computer to wait until a job is ready, and during that job, all it does is check their name, kick their ass, and when that's done, it marks their ass as having been kicked. and the job as completed. And Bill Gates was probably like, well, tell me more about this chunking it out, like into manageable pieces. And Paul Allen was like, yep, manageable pieces where the CPU can keep the job workload in the correct order and then map it correctly onto the screen or disk. And Bill Gates was like, well, what about this? We get a list of all their names. Doesn't matter if they're in order at first. We just get a total number of the names whose asses we need to kick. Then we get a clean divisible unit to divide the names. Then we sort them alphabetically. Then we actually divide all the names into individual workloads, groups, and jobs. And then Paul Allen was like, well, well, if we do it that way, then we could theoretically use multiple computers to do this. Then we could get it all done even faster. And so they would have conversations just like this for hours, days even. But every hour added up to every day added up to every week added up to every month, and every month added up to every year. And as the years flew by, they would start to figure out what idea would work out best for each scenario, just by hearing someone talk about what the requirements were. Method 1. They kicked asses without taking names, just a constant onslaught of ass-kicking, no name-taking. Method 2. They got everybody's name, sorted them into alphabetical order, and then effortlessly kicked all their asses in that order. Method number 3. They got everybody's name to get the maximum number of names of the people whose asses they needed to kick, and then they chunked it out so that they had some sort of unique identifier that could not be duplicated or amended. A unique identifier means even if 2 or more people had the same exact name, and then there's zero chance that they call the correct name but wind up kicking the wrong person's ass. Because if you try to recall objects by their name in programming, it might not be a unique name. It might be one of many names. There's not many scenarios where this happens. Well, in programming, there are plenty of scenarios where this can happen. But it's good to go by a unique instance rather than a name. And that's what a unique identifier links to. A unique instance is basically an object that has, the index, the name, the ID, and the ass, right? That's an instance. And the unique identifier is basically an identifier that finds that unique instance. So then with that unique identifier, they were able to procedurally kick all of their asses because they were able to call each name in order. And then after each name was called and each ass was kicked, they marked that ass as having been kicked, leaving a trail of asses that they kicked and how they did it. Method 4, they did something similar to the above 3 methods, except they were able to use multiple computers with a distributed workload so that one computer could work on one chunk of names/asses while one or more other computers worked on other predetermined chunks of names/asses. Then the 2 or more computers could return separate records of completion, so when they were all done with the jobs, they could tally them all up at the tail end onto different pieces of paper or files. Method 5, keep writing new methods that use some combination or variation of the previous 4. And that is why they became the founders of the company which continues to engineer the world's best software. Every single one of these methods allowed for them to create a company called Microsoft, where it didn't matter if they were set out to just kick ass or take names, or some combination or variation of the two. They just had a vision and a plan to do just that. And now, in the scenarios above, it might just sound like nonsensical babbling, but I'm actually introducing the idea of multi-threading and resources like processor overhead, memory limitations, and disk speed. It also bears great similarity to some things I've been working on recently and in the past. So I would like to demonstrate this utility at some point, which I'm not going to talk about it right now because it takes like an hour to run, but it's the snapshot utility, snapshot controller, which utilizes multi-threading or run spacing, and it's mostly coded in C# now, although it creates a initial session state PowerShell run space pool in order to go through all of the Windows event logs and then to get them all into chronological order and then be able to export it to a binary. And then the binary will contain the provider names, the log provider names, as well as various information of the system. It's effectively like a forensic level snapshot utility, but I still have plenty more to do with it. So let me get back to this and this. All right, so yeah, all those limitations set the rules on how to go about methods one and up, and really it was always those limitations that helped them bolster their skill set. And with that skill set, they could tackle new problems that they never dealt with before in an extremely effective manner. And Microsoft is not the only company that is well acquainted with this process. Like, Apple is well acquainted with it, Google is well acquainted with it, and basically every one of those companies in that list that I mentioned above, they know how to do all this stuff, right? But Microsoft was basically a pioneer in doing all this. They weren't ones to be satisfied by one singular approach. They had to mix and match old methods and occasionally stop and create new methods in order to solve those problems many different ways. And sometimes they would figure something out later on, only to realize something they once built could be updated to take advantage of a new method. The conversations above probably never happened verbatim, but in some respect, these skits definitively and realistically characterize someone's ability to engineer software. They probably also come off sounding a little bit like the middle out scene from HBO's Silicon Valley. Any software engineer out there is going to be very considerate of limitations as they're building an idea. Those limitations may be mental, physical, or some combination or variation of the two. And those who experience what it's like to be physically and or mentally limited by something firsthand are going to wind up building the best, most efficient, scalable, reproducible, and persistent solutions possible. That doesn't really happen any other way, which many developers today over-engineer their software. Take a long, hard look at large updates for games these days. I think there was a game that I saw, like Ark or whatever. It's like a 200 gigabyte patch. That's ridiculous. And I know I've heard that the game is very large, but like at that point, you're only catering to like high-end PC gamers. And like the console games, if they have like a 20 gigabyte patch, someone's got to wait and download all that stuff. And I can guarantee you that like a lot of the assets in those patches are reproduced somehow. So I think that people are not making the time to reduce the size of updates, or making the time to look through their code and try to apply a much smaller version of an update that accomplishes the same end result. So yeah, in nearly every case, they were in too much of a rush to reduce the size, and I stand by those words. Microsoft is not impervious to that. Sometimes they do the same thing. So anyway, you can build software that by asking a bunch of GPUs what to do, but ultimately those GPUs are going to start producing incorrect results, or start lying to you, or lead you down a rabbit hole, or send you down a wild goose chase, where for every time you take one step forward, you have to take 10 steps backward, though that definitely varies. Sometimes you take 2 steps forward and 0 steps back, so you have net steps of 2. Other times you take 2 steps forward and 5 steps back, which is a net step of -3. Sometimes you get to the quote-unquote finish line only to realize that you got to build the whole goddamn thing all over again, which is like, -500 steps. That's why the world's best software engineering has always happened at One Microsoft Way, Redmond, Washington, 98052, USA. It's kind of getting to be like a broken record at this point, but for a good reason. Now, I'd like to conclude with a special statement that I've said before but never finished. In the movie Doctor Strange, the Sorcerer Supreme says to Mordo, "We never lose our demons, Mordo. We only learn to live above them." And what that line basically means is you can either be consumed by your limitations or demons, or you can figure out a strategy to keep them at bay. This is a never-ending process. And further to that point, everybody has them. So don't take the phrase too literally. Everybody has their own metaphorical quote-unquote demons that are either chasing them or controlling them like a little puppet. So I've amended the phrase to sound more like this: though we may never be free of our demons, we can learn to live above them. However, in order to be the best quote-unquote wizard in existence who manages to do just that, you have to accept the reality that time continues to present new situations that have never occurred prior. There will always be some elements of new situations that have occurred before, but you may have to find a new way to make the pieces fit, like polymorphism. So I'm not even going to raise any exceptions right now, because there's plenty of current events that I want to talk about that will taint this whole recording altogether, so I'm not going to do that. In many cases, you may have figured many things out, ways to deal with different situations. You may have solved a particular problem beforehand, but an approach that worked before may not work each and every time in the future due to entropy. So you have to jump into abstraction, which is the entire point of this document. You have to conceptualize ways to break things that worked before, because if you don't, someone else most certainly will, due to entropy. And it's best to do that as you're developing the solution, not as an afterthought. And AI is just a tool. It can't do all that thinking for you. And stay frosty. So that really is the end of the document. And yeah, so I've updated the banner. You saw the previous version in this video. This is mostly the same. But here, let's bring this back down a little bit. Object. So I kind of want to talk about the code behind now. So object.type is an enumerator. Get. I don't know why that's doing that. Why is that doing that? Yeah, well, here. I can close that and then reopen it. Hopefully. I don't know why the console just decided to do that. I guess I'm going to have to close this. And then reopen this. Alright. So, yeah, I do kind of want to talk about, like, what I just did. So, I have the file locally on the system here. So, right here. Right theme. And then, what I'm going to do is, because I want anybody to be able to, like, you know, run the code that I just ran to roll that demonstration or presentation. Right? And I'll probably put this code... I have put this code on the GitHub, but I'll put a link to the video description if anyone wants to, like, see, you know, how I managed to do all of that. So, first and foremost, this is what I want to do. So, object, talk about the code behind. You know, I'm probably not done with the right theme stuff, but this is basically all the code behind. Object type, get enumerator. Get type, system enum, template type, right? And then palette. So I could change the palette, set palette. You know, the different colors that it was showing as I was doing the demonstration there. See how I changed all that, and I didn't really have to feed it anything different. I can continue to do that. Different colors. So some of the colors are locked, like everything in the flag, the background and the flag back. I kind of wanted to make these white, but for whatever reason the console host won't let me do that. So I'm gonna have to get into, like, using ANSI to render that. But yeah, as you can see, this is, like, way faster than it was before. And yeah, I have this IO object, which will take the input, output. So, in order to insert all that into the template, it's got to process all of that. Or, let's see. You know what else I could do is do this. So all of that is like random stuff that I just fed into the method there. All right, and then if I want to make a draft out, get the draft view, I'm gonna have to fix the way that the ruler is lining up in that specific case, because there's like over 100 lines, so I moved it over another thing. I thought I coded that in, but I don't know, the various things that I find out after the fact. But then there's the dev mode, which is pretty useful actually. Puts it all into, yeah, see, that's shown correctly. But then, you know, it's rendering everything with the correct colors, and it's I can change it. So set palette. See, it changes all that, so it's not really hard coded in there. And yeah, it's pretty cool, I think. But let's talk about the code behind again. Object.io, right? And you know, you got the input in the input spot, and it knows how many rows. It knows what type of input object it is, so we'll generate that template based on the fact that it's, you know, that high. And then the output is like the formatted value of the table. I still have some stuff I want to tweak to it. Right, it'll accept hash tables. This is a hash table right here. This is also a hash table, the third hash table. Like if you look here, hash 1, hash 2, hash 3, same exact information, but it wasn't maintaining the order. So then I came up with a new method that accepts a script block. So if it's a script block and it's only one line, then it will see it as like a hash table without that. If I do that, it'll look like a script block. But then you can also submit an actual script block, like one that's way up here. This script block, it parsed that all correctly as it was submitted. All right, so that IO object basically controls the rest of what this does. So the GUID, be able to use something like that with show toast notification, which is something I want to get back to writing. I want to integrate the toast notification function that I came up with. So this is the Fighting Entropy PSM1 file from, I think this is from 2024, January 2024. I have not updated this for a while because I don't want to break anything. You know, there's a lot of stuff I gotta update, and that I'm aware of. I know I need to update, but as you can see, a lot of these parameter names, they match in with this right here. So it's just a matter of time before I get the console object working with right theme. So anyway, yeah, every single time that a message came up, it came up during that presentation or demonstration. I had the current time. Like anybody could watch this video over again and see that, like, you know, I'm not pre-coding everything. It's dynamically inserting the current time into the prompt and stuff. And then the track. The track is basically all of the templates. Right? So like it'll know which line is the title. It'll know which lines are where the body stuff goes. It'll know where the prompt at the tail end goes. And then, you know, I could also do dev mode with a specific track number. And I'm going to have to fix that as well because that's not lining up correctly. But yeah, like these are the sorts of things that I was talking about in, you know, the software engineering document, right? It's like, this isn't going to reduce the functionality of the program, but, you know, if I want people to use it and they're going to see this, they're going to be like, whoa, this isn't done right. So it pays to be pedantic and to make sure that, like, all this stuff has been, you know, coded correctly the first time through. But yeah, it's just about it. Like, if I want to closely examine each individual track, let's say track 0. Right, and then I got a bunch of blocks. So I can see all the stuff in the first track. And all these numbers play into the palette. So if I go to object.palette, so 0 will reference the first number, which is 11. So the console will write a foreground of 11. And then 3 will render the third one in that array, which is black. So the background will be black. And by changing these, you're basically changing everything else. But let's see, template mask. So these are all string representations of PowerShell expressions. So if I do that, I'll get an array like that. So if I save it as a string like that, and then I can parse that and then reproduce that in C#, which is what I wound up doing. And then I managed to get a massive performance upgrade out of doing that. So anyway, I think that's gonna do it for. I think that's gonna do it for this video here. But I want to show one last thing before I close this out. So there it is. I know this showed up during the demonstration or the presentation, but if we go over here, we scroll down, you'll see that I managed to make a table and then format everything the same exact way that the console is formatting that. Let's say banner.dev mode. I'll do it again. So I'm kind of like in a pickle right now because this is supposed to be just a static method, and I wanted it to return that without, returning the object as well. So I have to think about what I want to do with that, but I think it really comes down to the fact that this is going to wind up being switchable like it was in here. Right, so all of these parameters, this is basically the most useful part about PowerShell, is how you can strictly set up the way that the commandlet binding works, so that I can use this as opposed to fighting entropy.theme.controller. Right. No, right theme is a lot shorter to use than that. And yeah, so all these functions will wind up just being wrappers over the namespace stuff. But anyway, yeah, that's a project that's going to take me a while. All right, 83,000 lines going through all that. In some cases, I'm going to wind up making it longer or shorter. And yeah, I think that's going to do it for this particular video. I'm definitely going to continue to work on this and then provide additional updates. I will wind up showing off this event log utility at some point that utilizes multi-threading, and then creates a snapshot that you can import into another system. Right, I think right now I could probably just do this just to show it off. Hang on a second. Alright, so so it's in the initial mode. Thread, that's the thread controller. And I will go over this at some point. I'm not going to do it right now because this takes a really long time to get everything on the system, and most of what it's doing only takes a few seconds. So at some point I will get theme to work with the console objects and the show toast notification stuff. But until then, that's going to do it for this particular video. Thanks for watching.